Hi everyone, we are going to look at 1.4 today, which is going to be talking about constraints. But before we do that, let's do a little warm up here. It says that the point is on the terminal side of an angle in standard position. Find the exact values of the six trig functions. Now there are two very important terms here: terminal side, standard position. Remember, terminal side means the ending side. So if I have the point -3, -4, that's just going to the left 3 and down 4. So there is my point. There is my angle. Now it says the terminal side in standard position. The terminal side in standard position, we are talking about making this triangle right in here. There's our theta. So this is -3, this is -4, and a squared plus b squared equals c squared. So we have 9 plus 16, which is 25, and the square root of 25 is 5. Now here's something to make sure you understand. This is your hypotenuse, this is your radius, and this is always positive. And so now if I label my sides, opposite, adjacent, hypotenuse, sine is so, cosine is ca, tangent is toa, and we want to make sure that we make that a positive. Cosecant is negative reciprocal. Secant is still negative, and the reciprocal, and cotangent is greater. Okay, now if we talk about constraints, I want you to think about x and y. X and y are positive, x is negative, and y is positive in quadrant 2. They are both negative in quadrant 3, and x is positive, y is negative in quadrant 4. So let's start talking about sine, cosine, tangent, and then obviously cosecant, secant, and cotangent are going to be the same. Sine is our y value here, so sine is positive. Cosine is also positive, and tangent is also positive because a positive divided by a positive is positive. Here, sine stays positive, but cosine goes negative, and that means tangent is also negative because a negative divided by a positive is negative. In quadrant 3, sine is negative, cosine is negative, but tangent is positive because a negative divided by a negative is positive. And in quadrant 4, sine is negative, cosine is positive, and since we have one of each, the tangent will also be negative. So that brings us to our next group of questions. State the quadrant where theta lies if. So both of these have to be true. So sine is less than 0, which means sine is negative, and tangent is greater than 0, which means tangent is positive. Well, sine is negative in quadrant 3 and quadrant 4. Tangent is positive in quadrant 1 and quadrant 3. So where do they both happen? In quadrant 3. Okay, look at the next one. Cosine is greater than 0, which means it's positive. Tangent is greater than 0, which means it's positive. Cosine is my x values. My x values are positive to the right. Tangent is positive in quadrant 1 and 3. So theta lies in quadrant 1. Now, we didn't put cosecant, secant, and cotangent on our chart over here, but it's the same thing. Cosecant is the same as sine. So when is sine positive? Sine is positive in quadrants 1 and 2. Cotangent is the same as tangent. And when is tangent negative? In quadrants 2 and 4. So this lies in quadrant 2. So you try one real quick on your own, looking at the secant and the tangent. and hopefully you ended up getting quadrant 2. The secant is the same as cosine, sine, and the tangent is already given. So this is how we're going to use this. Up until this point, basically, we've been looking at all of our thetas or our triangles being graphed in just quadrant 1. But now we're going to have some constraints. So this is saying that the tangent of theta is 15 over 8. We know that tangent is TOA, opposite over adjacent. However, this is going to give us our constraint to help us know what or where I'm going to put this in, what quadrant. So we know that tangent is positive in quadrants 1 and in quadrant 3. But this is saying that sine is less than 0, so sine is negative. Well, sine is my y value, and it's negative in 3 and 4. So that tells me that this triangle now has to be drawn in this quadrant. Theta always comes out of the origin. Tangent is opposite over adjacent, so opposite is 15, adjacent is 8. However, what do you know about the values going to the left? They're negative, and the values going down are negative. And now, if we take a squared plus b squared equals c squared, we are able to find our c. 225 plus 64 gives me 289, and the square root of 289 is 17. Remember that the hypotenuse is always positive because it's the radius. So now sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, and a negative divided by a negative becomes positive. Cosecant is negative 17/15, secant is negative 17/8, and cotangent still is a positive, but we're going to have a reciprocal. So look at the next one. It says that sine of theta is 0 and cosine is negative 1. Where is that line? Well, think about it. Sine is my y value, cosine is my x value. So when is x negative 1 and y 0? That happens over here at pi. Is there a triangle I can draw? I can't. But I still can find my sixth trig function. So sine is 0, cosine is negative 1, tangent is y over x, or 0 over negative 1, which is 0. When I flip 0, I get 1 over 0, or undefined. When I flip negative 1, it is still negative 1. And when I flip 0, I get another undefined. So not always are you going to make a triangle, but you still need to have an x and a y value so that you can find the six trig functions. So look at this one. It says cotangent is undefined and theta lies between pi and 2 pi. So if I know theta is somewhere between pi and 2 pi, cotangent is undefined, which means the only way on my unit circle that is undefined is if there's a number over 0. Well, it's either going to be 1 over 0 or negative 1 over 0. Tangent is y over x. Cotangent is x over y. So it's either x over y or negative 1, 0, or x over y or my point 1, 0. Well, negative 1, 0 lies right here. 1, 0 lies right here. Which one is it? guess what? I made a mistake on writing this out. This should have said theta lies between a half a pi and 3 pi over 2. So that changes things from here to here. So which one are we actually using? We're using our values at pi again. I'm sorry. So if we know that our x value is -1 and our y value is 0, cosine is -1, sine is 0, tangent is y over x, or 0, cosecant is undefined, and secant is -1, cotangent is undefined again. So we're using these constraints to help us figure out what point on the unit circle we're actually using.